Hey class, Mr. M here with a quick tutorial on finding arc length. We did a warm-up like this in class, but perhaps you were absent or didn't follow what was happening, and here's a quick tutorial. So here's our question. We have this scenario with a 10 centimeter diameter circle and this kind of angle, which is called an inscribed angle. We've seen that time and again. And its measure is 20 degrees, and our question is find the length of arc PQ. So let me get this out of the way. A couple things we need to realize here. Arc PQ is not 20 degrees of rotation. So think to yourself, how many degrees of the circle is this? And hopefully you've realized by now that there's a 2-to-1 ratio between the inscribed angle and the arc, and that's 40 degrees. And one way to recognize that is that the central angle, which is created right here, these two are the same, but this is half of it. And I go back to the analogy of a bow and arrow, and you're stretching it back and then elastically stretching it back farther. It's going to become smaller. So this is 40 degrees, that's the central angle as opposed to the inscribed angle, and 40 degrees is on the outside. Now there's two ways to go. I'm going to show you the proportion way, and then I'll show you the formula. But the proportion way says this. We know how to find the length of the entire circle all the way around. And I'll do that in black because the circle's all the way around. The length of the circle all the way around is called the circumference. So circumference is given to us by pi times diameter. That's the definition of pi, is the ratio of circumference to diameter. So in this case, this would be pi times the diameter 10. So pi times 10 will give us 31.4 centimeters. So all the way around the circle is 31.4 centimeters. So I'm going to put that on bottom to represent the entire whole circle. And on top, I'm going to put the part of the circle that we want. How long is PQ? Well, we don't know. But we do know that it represents 40 degrees of rotation. So both of these represent just the part that we want, which is over here. Right? The tops of our fractions represent the part. The bottom of these fractions will represent the whole, W-H-O-L-E, the entire thing. Well, these are both in length measurements, centimeters and centimeters. Well, what is the degree measure of a whole circle? Well, we all know that. That's 360. And thus you have a proportion. And I'm going to quickly multiply both sides. So I'm not going to cross multiply directly. I'm going to multiply both sides by 31.4. And since x is being divided by 31.4, that'll have the net effect of canceling it. And this will give me, on the left-hand side, x, in black, is equal to, I'm going to leave that fraction as is temporarily, 40 over 360 times 31.4. Now keep in mind what that 31.4 is. That is the circumference, right? That's where it came from. Throw that in the calculator and you'll get an answer. And that answer is, let me get the pen tool, that answer is 3.49. There you go. Now this picture is not really drawn to scale very well. This looks like more than 40 degrees. The important part really is to recognize, that should be centimeters by the way, that the important part is to realize the relationships, and that's the part to whole ratio. So the reason that I wrote it out like this rather than cross multiplying is to show you the importance of the following formula. And this formula is already on your foldable, and if you have been taking notes on previous videos, you've already actually seen this formula and an example, but I wanted to give you another one. Theta over 360, that represents part over whole. Circumference represents the whole circle, all the way around, and of course the wholes would cancel, leaving us with just the part. And that is why this formula works. Alright, hope this helped.